The next skill we want to look at are the different ways that we can solve a quadratic equation, specifically algebraically, graphically, and numerically. And actually there's a couple ways that we can do the first two, then one analytical skill that we have for the numerical. Algebraic, we can solve a quadratic equation really three main ways. We can factor, and there's a couple of different ways you can factor. We can complete the square, convert to vertex form, and then set the equation equal to 0 and solve. Or we can do quadratic formula. So factor, complete the square, quadratic formula, all legitimate ways to solve algebraically. The graphical, we're going to go to our calculator, and we're either going to use a zero function or the intersect function. And then finally, the numerical, we're going to use the table. And specifically on the table, we want to look for the x value where the y value is 0. So we're going to look for the x value where we've got a y value of 0. So f of x is equal to 3x squared minus 16x plus 5. We want to solve this equation algebraically using some factoring method, graphically at least two ways with the intersection function and the zero function, and numerically. So let's start out by doing this algebraically. Now we could use factoring, completing the square, the quadratic formula. Since I specifically say here factoring, let's do the factoring method since we've already done completing the square. And then the quadratic formula, if you need to write this down, would be x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I think you guys can plug into the equation where the first value is a, the second one is b, the third one is c. So I'm not going to work that one out. But let's solve by factoring. Just as a review of factoring, you can either factor out a greatest common factor, or you can do MAC factoring, or you can do factor by grouping. And with this one right here, 3x squared minus 16x plus 5, this one, since I've got this 3 in front, I just can't say what are the factors of 5 that add up to 16, negative 16. But I've got to say I've got this 3 in front. 3 times 5 is 15. What are the factors of 15 that add up to negative 16? And the factors of negative 15 or negative 16 that add up to positive 15. So we want the factors of 15 that add to negative 16. That would be negative 1 and negative 15. Negative 1 times negative 15 gives me the positive 15, but negative 1 plus negative 15 adds to be negative 16. So here, 3x squared minus 15x minus 1x plus 5. I substitute these two values in place of the negative 16, negative 1x and negative 15x, which I put right there. Then I can do my factor by grouping. What can I factor out of the first group? Well, I can factor out a 3x. I'm left with an x minus 5. In the back, I can factor out a negative 1, which then leaves me with the x minus 5. These two pieces have to be identical. I can then say my two factors, it's everything outside the parentheses that's not inside the x minus 5 and x minus 5. So 3x minus 1 and x minus 5 are my two factors. Now, since my goal here is to find an x-intercept, that's the same thing as finding a 0 or finding a solution, I would set each factor equal to 0 and solve. So here, x equals 5 and x equals 1/3. That's one way you can solve algebraically using factoring. You could have used quadratic formula or completing the square and gotten the exact same result. The second now, let's look at this graphically. And there's a couple of ways that we can do this. The first way is with the zero function, and the second is with the intersect function. So we're going to say y is equal to 3x squared minus 16x plus 5. So here's my calculator. And I've already got that plugged into my calculator, 3x squared minus 16x plus 5. Let me just go back to my standard view. There's my parabola. And my solutions are where this graph crosses the x-axis. Now, since we solved this algebraically, we know it's going to be a 1/3 and a 5. But how would I find that if I did not know that already? And there's two ways we can do it. One is the intersect function, and one is the zero function. Where you're going to find these functions is under second trace, or the calc menu. So we'll go second calc, and option number 2 is 0. When I'm trying to find a 0, I'm looking for a left bound and a right bound. A left bound is any value to the left of where the 0 occurs, and the right bound is any value to the right, specifically the x value. So here as I'm going along, I know that my x value here, my solution, is going to be 1/3. So just for argument's sake, I need to choose something to the left, something less than 1/3, which here 0.21 would work. I can also see that that's above the x-axis, which is okay. My right bound then has to be beneath the x-axis, or a number that is larger than that 1/3. And then finally, the guess is something in between, but you can just hit enter and it'll guess it for you. So you can see right there, my first 0 is at that 0.3 repeating, which we know is 1/3. And we'll do the same thing again. We'll do second calc and go to 0. And this time we're going to scroll over all the way around. There we are. To the second 0, which I know is going to be 5. Left bound, I need to choose a value for the x that is slightly less than 5, which is 4.89. So I'm going to be right there. Since my first point was beneath the x-axis, my second point has to be above the x-axis. And as soon as I move above the x-axis, I can see I'm at 5.1, which there's my 0 at 5 and 0. So that's how you use the zero function. You choose something that is to the left, something that is to the right, and when you do that, one value has to be above the x-axis, one has to be beneath the x-axis. So that's the zero function. So the zero function is going to be second trace option 2, and you're going to do the left bound, right bound. The second way we can do this is with the intersect function. And the intersect function takes two functions and figure out where they intersect. So if my given function is 3x squared minus 16x plus 5, I need to come up with two functions that would intersect. So one example of this would be y1 that I plug in would be 3x squared minus 16x plus 5. And then maybe y2 would be 0. So let's do that. It's the exact same thing as we already have set up. And then we put 0 in for y2. And then I hit graph. And you're really not going to see any difference right here. But what I can use now is under calc, I can choose option number 5, which is intersect. And when I intersect, I just go as close as possible to where the two graphs are going to intersect, and I hit enter 3 times. Get as close as I possibly can. And you can see the intersection right there is 1/3. If I do the same thing again, head over to intersect. My first curve, which is my parabola, my intersection is pretty close right there. Hit enter. My second curve guesses where the intersection is going to be. Hit enter, and then I guess, and I can see there it's at 5, 0. So with the intersection, you don't have to worry about left bound and right bound. You sort of guess where the intersection occurs, then hit enter a bunch of times. But there's other ways we could use the intersect function. I can choose 3x squared minus 16x plus 5 and 0. Or if I wanted to, I could say y1 would be 3x minus 16x, and then y2 could be a negative 5. Basically, all I'm doing is I'm taking this equation here, which is really 0 equals 3x squared minus 16x plus 5, and manipulating it in different ways. So I can move the positive 5 over here and make it negative 5. Or I could have y1 be negative 3x squared, and then y2 be negative 16x plus 5. I would get the same answers. That one, I'd be manipulating this to move the negative, or the 3x squared to the left-hand side and making it a negative 3x squared. So any of those ways would work. Now, the thing that's different about that is, let me take the second example, this 3x squared minus 16x and the negative 5. If I were to put that in, my picture looks completely different. 3x squared minus 16x and then negative 5. You can see I've got a completely different parabola and a different intersection line. But if I go second calc and I go intersect, and I move down close to where that intersection is, you can see my x value, which is what I'm trying to solve, is still 0.3. And if I do the same thing with my other intersection, it's still going to be 5. Because I'm only really concerned about that x value. So there's 5 there for my x. So that's how we can solve graphically, using the 0 function and the intersect function. The final thing then is, how do we do it numerically? And numerically uses the table, and we look for where the graph is equal to 0 in the y column. So we'll go back and we're going to put in 3x squared minus 16x plus 5. And this time we're going to hit second table. And let me change my table so that I'm at 0 and I go up by 1. Now when I look at this table, I can see right here 5 and 0. This is going to be one of my solutions, because in the y column I've got a value of 0, which gives me an x-intercept. Remember, x-intercept is the same thing as zeros, or the same thing as solutions. So 5, 0, if I look at this table. Now the other one, if I were to change my table so that my change in table is 1, whoops, go back to that. And I want to change my table to be 1/3. There I can see at 0.3 I've got 0. And then if I keep scrolling down, I'll see at 5 there's my other 0. So I can find both of them if I have my scale set right. So numerically is often a little bit more difficult unless you already know what the answers are you're looking for, or the direction that you're looking to go in with that. So just to summarize, algebraic, you can use factor completing the square quadratic formula. With graphical, you use a picture, and you either use the 0 function or the intersect function. 0 function involves left and right bounds. Intersect, you take two equations and find the intersection of them. And with the intersection, there are many different ways that you can write it. And then finally, numerically, as you look at the table, and you want to look for x-intercepts. And x-intercepts are when the y value is equal to 0. So specifically, you're looking for the y value equaling 0.